Hey everybody, Dr. Cody here. As promised in the review video of the Mendi fNIRS wearable device, here's my full interview with Chief Technology Officer Rickard Eckloff from Mendi. If you want to get the most out of your device in terms of understanding how the sensors, calibration, and focus parameters work, take a look here at my interview with Rickard. All right, we've got Rickard Eckloff, co-founder of Mendi and engineer as well on the Mendi team. So I'm really excited to talk to you and hear more about how Mendi is designed and where you see the company going in the future. Thanks for joining, Rickard.
Yeah, super happy to talk to you, Cody. Yeah, it's really exciting. This is kind of my baby, so to speak. I've built it from with my own hands. Hand soldered the first 25 devices. It took about 5 hours each. So I know all the ins and outs about it.
Yeah, your technical background is really interesting because of just, like you said, you know, the ins and outs of the device. Could you give us a little bit of your background and how you came into co-founding Mendi?
Yeah, sure. So I've always been a very curious person. I always wanted to learn how the things work. And I think it started, I remember I got a book from my dad when I was like 6 years old or something called How Does It Work? Basically explaining how, you know, airplanes work and like, I don't know, engines or whatever, bunch of stuff, and a lot of pictures and easy to read text. And I was reading that thing apparently every single day for a few months. And naturally, I became an engineer at the Royal Institute of Technology in Stockholm. I wanted to understand how computers are made, how you manufacture them, how you design them, what are the pros and cons of choosing a particular architecture or what have you. So I had that goal in mind and I just did that. I just spent 5 years understanding those things, specializing in embedded systems, so microcontrollers. And after that, I started working, and the first kind of most exciting job I got as an employee was at a place called Neonode, who was they invented the slide to unlock feature. They patented it, which was really a big thing back in the early 2000s. And they did optical and still do optical touchscreens. So I spent a lot of time working with optical engineers, electrical engineers, software engineers, all types of engineers to manufacture low-cost optical touchscreens for consumer companies like Dell and Hewlett-Packard, Sony. So I was working with a lot of optical engineers and mechanical engineers and software engineers, and we were developing optical touchscreens for the largest consumer electronics companies in the world, like Dell and Amazon and Barnes & Noble and Hewlett-Packard. So I learned a lot about how basically to transmit and receive light over a surface area. And spent 5 years doing that and really became knowledgeable in that area. So that's like my biggest, I think, engineering feat in the early career. Then I resigned. I quit my job because I wanted to try my own wings and jump on a few other projects and find like-minded people who also wanted to build something from the ground. And I started doing a bunch of different projects like solar energy optimization. Like I did some sort of sensor for figuring out how ground is moving in a 100-meter deep hole, and some other interesting things. And then one of the colleagues I had at one of the places I rented a desk at, he explained or showed to me the concept of neurofeedback. It was the first time I got introduced to that thing, and I was instantly intrigued because he showed me his little gadget where he put on an EEG sensor on the temple and another one on his earlobe, and he had written his own PC software where he adjusted the opacity of the display based on the readings from the EEG device. And he told me that he did this, still does every morning for about 10-15 minutes to get rid of his migraines. And I thought that was super interesting. Okay, so this piece of technology can actually get rid of migraines. Okay, that sounds a little bit too good to be true. So I started reading up on the science. I started trying to find scientific literature, had done studies on. I started with migraines, but then eventually I saw that neurofeedback is about so many more things, like anxiety, insomnia, etc. And I also saw that the studies were quite small. There were not any large clinical studies on like thousands of people. And I also saw that a lot of the results were very promising. So instead, it would be maybe one participant or 10 participants or 15 or so. And the conclusions were pretty much it's a positive, seems to be a positive result, but more studies are needed to verify. After that, I started looking into the technology to figure out how do you even build such a thing? Is this hard to do? How do you do it? Can you bring the cost down? I saw that these devices were available for $10,000 up to $100,000. And I thought to myself, that's not what it costs to build such a thing. It's possible to make it a lot cheaper. And it's even possible to do with consumer electronics that you can build your own. And I started to design my own then. When I met my co-founder. So I actually met him when I was researching competition and other types of companies who are doing this kind of stuff. And he was running a brain training clinic in Sweden, in Stockholm, very close to me. And we just decided to start a journey together. And I started building the first prototype.
We had talked before about, I think you had mentioned that you would have gone with whichever modality you felt like would work best for neurofeedback. It didn't have to be fNIRS. It could have been one of the other ones. Can you talk a little bit more about how you centered in on fNIRS and why you thought that would have been the best route to go for a neurofeedback device?
Yeah, there are a lot of different aspects, I think, to this question. One quite important one is that I think just looking at the different technologies is that EEG is great and all, but it has the deficits of EEG is that it's a very average type of technology. And what I mean by that is that it captures many neurons all across the brain and gives you one output in the frequency domain saying, yeah, basically your brain in this area averaging at around this frequency, whether that's alpha, beta, or theta, or whatever. Well, that's super interesting. It doesn't say that much about that particular local area of your brain. So when you talk to neuroscience researchers and laboratory people, they are actually more interested in using the fNIRS approach or a combination of both, because fNIRS is a local measurement where you measure a local area. So if I had a sensor in this area, I wouldn't catch the readings over here. They would only be in this area. And why is that important? It's important because you can draw more conclusions based on that. You can do the things that is called functional imaging of the brain, meaning I can see dependent orders of different areas of your brain lighting up in a specific order. And that's how you map how the brain works, really. And that's how researchers do that nowadays, is that they don't just look at the connection, the white matter between different parts of the brain. They actually look at using imaging technologies to figure out which parts are connected to what other parts and in what order are they triggered to figure out the root and cause of effect. So that's one of the biggest things. The locality is much better.
Yeah, it's so interesting. Maybe we should back up a little bit and explain what fNIRS is. I think a lot of people watching my channel have heard me talk about this technology before, but I'd love to hear your explanation about it and how this actually is able to measure things like blood flow in the brain.
Yeah, it's actually really cool. It's basically shining a flashlight on your brain because it's electromagnetic radiation, so light. And you're choosing specific wavelengths, so you engineer it in such a way that you can infer characteristics of the blood flow in that local area that you're measuring. So if you think about your body, there's this vascular system where your blood is just going around and around in a circle, and it's the heart that's the engine. It's basically pumping it around, and then it passes through the lungs, and the lungs oxygenate the blood, and and eventually you exhale carbon dioxide, right? So there's been done a lot of experiments looking at what is inside of the actual blood that goes around your body, and there's a particular protein called or molecule called hemoglobin. And hemoglobin is interesting because it can carry oxygen very, very well, and it can release it very well as well. So that's basically the carrier of oxygen inside of your body. So hemoglobin can either be oxygenated, meaning it has bound oxygen to it, or it can be deoxygenated, meaning it has released the oxygen to some cell. Why is this important? Well, all cells in your body, including your neurons, who are also a particular type of cell, require oxygen in order to work, basically. And hemoglobin is such an efficient carrier of that that it's really important for your function. So what engineers and researchers have found out is that if you shine light of different wavelengths on oxygenated and deoxygenated hemoglobin, they interact with that particular wavelength of light differently. And based on that, you can calculate the amounts or the relative levels of oxygenated hemoglobin versus deoxygenated hemoglobin. And that's why you can infer that this local area, for example, holds more oxygenated blood flow than another area.
Is that a function of both the oxygenation of the hemoglobin and the amount of blood flow in the area, what the signal is picking up?
Yeah, so you can think of hemoglobin as, if you add them both up together, deoxygenated and oxygenated, that's your total blood volume. Say that's the total. So basically, when you do fNIRS, so the spectroscopy type in functional infrared spectroscopy is that you measure both the oxygenated blood flow or hemoglobin and the deoxygenated. And if you look at the total blood volume, the addition of the both, you will actually see increases and decreases in that as well, depending on brain function. And for example, other like cardiovascular function, like moving your, for example, contracting a muscle and so on, you'll also be able to see the same effect.
Is there any way to parse out in the reading that comes from fNIRS devices how much of the increase is from oxygenation of the hemoglobin versus the increased blood flow?
Yeah, it's inherent in that same calculation. You basically just use that addition. You know that hemoglobin is either oxygenated or it's not, and the sum of that is the total amount of hemoglobin and therefore your blood flow.
So you can tell in a signal if it's more oxygenated or if it's increased blood flow that's increasing the signal?
Yeah, we can see both the increase in blood volume and the increase or decrease of oxygenation of the hemoglobin.
So earlier you said you had seen devices that cost $10,000 to $100,000. Were these the gold standard fNIRS devices that you were looking at, and from your background thought that it could have been done for much cheaper?
Well, it's funny. There are three types of fNIRS technologies out there. There's continuous wave, there's frequency domain, and time domain. And like engineering-wise, they're very different, and they have different, capabilities then, of course. But even the cheapest one, which is continuous wave, cost in the tens of thousands of US dollars. And that was just kind of mind-boggling to me why that's still a thing. Because I could just see that you can make this so much cheaper and much more available than what they are. But basically, there are these, I guess, big corporations from before that have done this for a very long time, and it requires domain knowledge, and it requires a lot of testing and a lot of and then I guess there was no market either for this type of product to mass produce it. So why should you if you only sell 100 of them per year, why would you reduce the price, right?
Right. So which one of those three is Mendi?
So Mendi, this generation is based on that continuous wave technology, which is the, well, I would call it the simplest one, but it's also the most used one in research as well. So it's not just that it's easy to make or is cheap to create or something like that. It's also that the one that has been used the most by researchers, meaning you can recreate the results better because you have others who have done that. And there are also a lot more devices of that technology on the market, like, I mean, for researchers. So you can compare to other companies, and you can compare to other researchers the results. So it's the most commonly used technology, and the reason why is that the difference between them is that frequency domain and time domain fNIRS, they measure it, or they can measure absolute values of oxygenation, oxygenated hemoglobin and deoxygenated, whereas the continuous wave one can only measure relative difference. So that's what Mendi uses. And what that means is that relative to a certain point in time, you have now increased X% or decreased X%. And that's why you have that percentage in the Mendi app.
Is that why you need to calibrate before each session as well?
Yeah, that's one of the, but the calibration is also about looking at the signals and figuring out what the environment looks like, if there's a lot of LEDs around you, or capturing the data. So basically calibrating the signal processing that goes on live in real time during the actual session. So actually the actual calibration is more about you clearing your mind rather than calibrating the sensors in a particular way. It's more about you recalibrating yourself and setting a steady baseline of your brain or your prefrontal cortex as you go into the training experience.
I didn't realize that. So part of that, the function of that is just to make sure that the person kind of settles in and isn't moving too much before the session starts.
Think of it like this. When you perform a cognitive ability, for example, you solve a really challenging math puzzle or something like that. What happens in your prefrontal cortex then is that it's going to activate, and it's going to consume more oxygen and require more oxygen to be delivered to that part of the brain. And eventually your prefrontal cortex will tire, and you won't be able to sustain that activity then, and it'll drop. And basically, when we connect this to the Mendi product or the training experience in the product, we want you to have that clear mind just before you start doing that complex math puzzle, before you start, instead of starting at a high level and then trying to increase the activity from an already high level, which doesn't make sense. It makes sense to start from a lower level. So we want you to kind of clear your mind in that calibration period to get ready for getting the work done, so to say.
Amazing. So I know you guys have worked very hard to develop the technology for Mendi, and I don't want to ask you to share too many intellectual property or trade secrets, but as much as you would be willing to share about how the light sources and the sensors are set up in the Mendi, I think that would be really interesting for the audience to hear about.
Sure, I have one here, and this is the where the magic happens, so to say. You have the emitter, basically the flashlight then that is going to shine a light on your head in the middle, and on the farthest point away you have a sensor, and basically the light coming out here takes a banana-shaped path through your prefrontal cortex and reaches this point eventually. And we capture it there. And that's why we read the oxygenation and deoxygenation between these points. So this is 3 centimeters, so 30 millimeters. I don't know what that's in American units, but And basically it penetrates half of that. So it penetrates 15 millimeters into your skull. And on the other side, you have a symmetric sensor, the same, 30 millimeters here. So it's basically measuring your left and right half of this Brodmann area 10 around here. And then we have a third sensor right here. This is the one that's a little bit closer to the emitter. This one, again, reaches only half the depth, or sorry, reaches only half the width of this distance. So it's only reaching about 6 millimeters down. And that doesn't reach the brain itself. It only reaches the skin, a little bit of the scalp. And the reason why we do that is for calibration purposes, because you have a lot of blood flow in your skin as well, of course. And we can use that information and in real time subtract it from the actual sensors that are measuring your neural activity. So it's basically the way that you get rid of what's called systemic artifacts like blood pressure or Mayer waves or whatever have you. It's a lot of technical words there, but it's a calibration method. But on top of that, we also use it as an HRV sensor because it's really good at capturing your pulse. It can scan up to 250 hertz, meaning you can get a really good signal quality on your pulse at the time. We can really get those nice measurements of your heartbeats in the milliseconds then to calculate your HRV.
And that will be incorporated into future iterations of the app, the HRV, right?
Yeah, for sure. So HRV is a really cool thing, and it's different products use it already on the market today. So we don't want to just copy and paste and add stuff that doesn't make sense, since they may already have an Aura ring or whatever have you. We want to make it part of the Mendi experience. So we're still exploring how we are going to Mendify it, but we think it's going to be part of the training as well, some sort of training instead of maybe not only measuring. So really going to be excited to let you know what we're going to do there. But for now, we have the hardware capability, and we're using it mostly for calibrating the device to measure your actual neural activity. But soon we'll also release some sort of training experience with HRV as well, because a lot of our customers have expressed their interest in it and wanna play around with it.
Yeah. There's a big biohacker and neurohacker community out there that are really excited to start playing around with this technology. Any chance they would have access to any of the raw data in the future?
That's also something that's definitely popping higher and higher up on our roadmap. More people are asking for it. A lot of partners are asking for it, that where you would have like programs and stuff. Let's say either you're a brain trainer or you are a professional institute of some sort. You would want more data to evaluate the athletes. So we're definitely seeing a lot more interest in that, and I think it's going to come out. Well, I can't tell you when, but it's definitely higher up on our roadmap than it was like 2 years ago.
Yeah, I know a lot of people in the Facebook and other social media communities would be really excited about that. So I'm sure they'll be happy to hear that you guys are thinking about it. Rickard, what would you say has been the most surprising thing as your baby has gone into the hands of the users out there in the world and started getting involved with the device? Is there something about the way that the brain functions in relation to fNIRS or how it's being used by individuals out there? What have been some of the surprising things that you've seen in the last year or so?
Well, I was quite surprised that quite a few, or maybe they're just more vocal than others, but quite a few of our users really like to do experiments. And an experiment could be something like doing Wim Hof breathing exercise while measuring neural activity with Mendi, or doing push-ups at the same time as trying to measure the neural. So that's something that really surprised me a little bit, and it's not really intended to do that. It would be cool for us to maybe even we could, if we did this type of platform thing where people can get the raw data and add their own signal processing, they might be able to work with that a little bit better by, for example, adding their own signal processing filters and stuff like that. Because a lot of the data is about filtering out noise. So noise that comes from, wrinkling your eyebrows, or, standing really close to an LED light or stuff like that. That just needs to be eliminated from the signal. And you use different software filtering to do that. And one of those things is, for example, doing Wim Hof breathing, is that, of course, you're going to oxygenate your blood a lot. And it's not neural activity. That's just more oxygen in your blood. And the Mendi captures that. So that was one of the big surprises, I'd say.
Yeah, I might have said this before, but I think what I've seen from the social media communities is there's a lot of skepticism that comes with these devices, and that even though it is its neural activity that is causing that change in hemoglobin oxygenation, it's nice to be able to see that you can have a direct effect over the device readings by doing something as tangible as increasing your breath rate. That way, it actually is tracking hemoglobin levels in the brain. And I think it gives people more confidence to use the device and know that it actually is measuring your brain function.
Right, absolutely. The only downside is when you're actually trying to measure neural activity, you have to remove those artifacts to get an accurate experiment. But I mean, it's each to their own. Like if someone wants to just see how oxygenated their blood flow gets by doing Wim Hof breathing with a Mendi, I mean, go ahead. It's not a problem.
Yeah, and I mean, the increased blood oxygenation is going to do something to your brain as well. So it's probably difficult to parse out what exactly is all happening in a scientific method. But part of what I love about these devices is that the everyday user gets their hands on it. It's democratized. So there's a lot of creativity, and people can participate in the discovery process with companies such as yours with Mendi.
I love that idea. It's one of these things where, so if you think about cause and effect, you have neural activity causes your body to increase the level of oxygenated blood flow to that area. Well, what happens if you do the opposite? What if you force a higher oxygenation? What's going to happen to your neural activity? Or what's going to happen to your neurons? Or what's going to happen to other things inside of your brain? And this is something that's not very well known in the scientific community. There's some talk about astrocytes and other types of cells that are around there that are affected by this, and maybe in a positive way, maybe, it's very unclear. The scientists it's really, really early for them in their journey to understand that. But to me, it's super interesting, and we can see, at least anecdotal, but I think also in studies that, getting more oxygen, for fact, in studies, getting more oxygen to your brain is good for you. And it's not caused by the neural activity, it's caused by something else. So what's going on there? It's going to be interesting to find out more.
Yeah, it makes me think a lot about aerobic exercise and how healing that can be for people. But I don't want to get too far off track. I wanted to ask you what you're most excited about in terms of what you're working on right now within the company. What project excites you the most when you get up in the morning?
Oh man, so we just hired our first in-house neuroscientist this past month, and he's working for us a few days a week now. But it was such a joy to spend the day with him today, talking about what's possible, what's the difference between attention and focus, what's really causing focus to be a thing, and how can you improve it, and what are the factors that are involved with that, and just all that stuff that comes with years and years of research. Having that experience in-house is such a game changer for us. We've been working with external consultants until now, and they've been great, but it's a whole nother level when you have someone in-house that's there every single day consuming all the stuff that we're working on. So that's super exciting. We're also making a lot of improvements to the product experience. 2022 is gonna change the product quite a bit. Super excited about that, giving the customers a deeper understanding of maybe not exactly what happens in the brain, but a better understanding. We want to highlight this concept of Mendi makes the invisible visible better for our users. So we want to give them this mirror into their brain that they deserve, and we're gonna work on that in the product itself. And then there's continual work on the brain health model that we've launched in just before Christmas, where we combine the sciences of neurofeedback and behavioral, lifestyle recommendations, basically changing habits in your life to improve your brain health or your ability to focus or these different things. So I'm super excited about all of those things.
Yeah, can't wait to see what comes up this year. I think we should clarify not any major hardware changes in the device this year, right? That if people want to purchase a Mendi, it's not going to change drastically within the next year.
No, it's going to be the same, Mendi. Yeah.
But you're talking about software and customer experiences within the app, right?
Yes, exactly.
Great. And along that same thread, where do you see, I know it's difficult to make predictions when a company is just starting out and getting going, but where do you see Mendi going in the next 2 to 5 years?
Oh man, it's I feel like this type of product in this type of world that we're living in is such a needed thing, something that can give us the insight into this black hole we have here, which we don't really understand that well, and we can't see it and we can't feel it either. Like, it's very opaque to us. If you're thinking about the attention grabbing economy that we have, and I just feel like people need to understand and need to get the opportunity to understand what's actually happening inside here when you're living your normal life, because it's not normal really what we were being exposed to nowadays. It's like our attention levels have gone from 45 seconds being able to concentrate on one thing for 45 seconds down to like 5 seconds today. You see mental health problems all over the place, and a lot of it is contributed or caused by our lack of attentional control nowadays. We think that giving people the tool to understand that and see, basically visualize what's going on in the brain, is going to be an important step to help improve that.
Yeah, as much as I love talking about the technology, I really appreciate you and the company's humanistic orientation, and you have a big mission. You have a big task ahead of you, and I love that Mendi is really trying to help the individual user gain control of their attention. Rickard, this has been such a great conversation. I've really enjoyed it, and I know the Techforpsych audience will as well. Is there anything else that you'd like to communicate to the Techforpsych users about the Mendi experience?
Well, thank you so much for having me, Cody. It's been great talking to you. And I just like to say that please give us feedback. Like, join the community, talk to us. We're very receptive to receiving feedback, getting feedback. How can we improve the product? Are there any ideas that you might have as a user or partner, or maybe you're working in a brain training clinic or anything like that? Do reach out to us. We're super happy to get your thoughts, your ideas, because I think this space that we're all in is going to evolve quite a bit in the next 10 years. So it's up to grabs, really. We together define what's going to be built and how it's going to work. So just make your voice heard. Please do that.
Thank you, Rickard.
Thanks, Cody.